Hi, this is Mr. Max. I'm continuing with my series on differentiation. I'm just doing a quick question on further differentiation. So what we have over here, we are told that the curve or equation of a curve is equal to y equals to tan over half of x plus 3 sine over half of x. And the curve has a stationary point. So this keyword over here is telling us that we will have to find the derivative at 0. So we'll have to differentiate that equal to 0. However that curve will look like, okay, its turning point there, the gradient of the turning point is nothing but 0. So if I was to show you, and I hope for the sake of this, that this curve is something that makes a bit sense. So let me just show you how that curve will be and what it all means. So if the equation is y equals to, of course, we have to go back and just get what that equation is. That equation is a very interesting value. It's a half. No, let's just quickly go back and find out. Well, it's a tan of a half x, so it's tan 0.5x. Okay, and then we have something else that is done to it, plus 3 sine plus 3 sine of 0.5 of x, 5 of x. That's it. Good. Now we are told that this curve has a turning point. Now you can see a turning point over here, which is 4 point something for the value of x. Okay, 4.6. Can you see that? We see another turning point here, of course, which is about negative 4 point something. Good. So we are going to attempt to see which one of these points is it that we're going to find. Remember the 4.6, which is where my point A is, more or less. So let's quickly go back and then differentiate and see. Good. So let's find the, first let me write down the equation. So that is y equals tan of a half of x plus 3 sine of a half of x. Okay. We can actually go ahead and we can differentiate. So dy by dx, that's going to be the derivative of tangent is sec square. Then you find the derivative of the inside, which is just a half, plus the derivative of sine is cos of a half of x times the derivative of the inside, which is a half. So the calculus is done. So what we're left to do is just to clean up a bit. So a half sec square times a half of x. Now remember that half, you should not multiply it over with the angle. And this half, I'll multiply it with this 3 over here. That is 3 halves of cos of a half of x. Good. Well, you can actually, if you want to, but let us go ahead then and set this derivative to 0. That is 3 halves of cos of a half of x. Let that equal to 0. So the first thing that I will be doing, I will do it step by step. I want to get rid of this 2. So I'll multiply each term effectively by 2, leaving me with sec square of a half of x plus 3 cos of a half of x is equal to 0. Now, sec, if you know your reciprocal identities, is 1 over cos square of a half of x plus 3 cos of a half of x is equal to 0. Okay, please remember that sec of x is the same as 1 over cos of x. Okay, so that is what I'm applying over here. Now I want to get rid of that fraction, so effectively I will multiply both sides by a half, cos of a half of x, cos square of half of x. So I'll multiply this one over here also by cos square of a half of x. Effectively, I also multiply the 0 by the same thing. It's just that if I do, I'm just going to remain of an answer of 0 on this side. This will be 1 plus 3 cos a cube of half of x. All right. We nearly are where we need to be. The idea is to isolate. So I'm going to say this is cos of a cube of half of x. Right? I have my 3 over here. It's negative 1 if you subtract both sides by negative 1. Then cos of a cube of half of x equals to that negative 1 divided by 3. And we need to get rid of that cube. And the inverse of cube is the cube root. So we're going to take effectively the cube root of both sides. So I'm just going to say, let's just go ahead and save, because I can already foresee problems. So this will be cos of a half of x is equal to the cube root of negative a third. Now, if we do the cube root of negative a third, we grab our calculator, and I would want you to make sure your calculator is in the radian mode, which mine is. But if it wasn't, you have to go to the setup and then you choose. So you will, in this case, this type of calculator will be choosing 4. So I'm going to take the cube root of negative 1 over 3. Cube root of a negative does exist. It gives you negative 0.69. Let me just go ahead and capture that. To rewrite that whole thing can be a little bit tricky. Good. Now, what this means for me, if I was to look at the what we call the cast diagram, and you know that this would be either 0 or 2 pi. This over here will be pi over 2. This over here will be pi. This is 3 pi over 2, okay, or 270 degrees. Now, we know from our work over here that the cosine ratio is negative in the second quadrant as well as in the third quadrant. In the first quadrant, it's positive. So I'll just go ahead and say, okay, I'm not going to then consider an acute angle as a solution. So I'm going to look at a scenario where that angle is in that quadrant or that angle is in this quadrant. But in order for me to do that, I will need to calculate what is referred to as the acute basic angle. Some people they just call it the reference angle. So what that means, I'm going to take, so first I'm going to say let this half of x, this stuff that is inside here, let's replace that by a letter k. This implies that I have got cos of k is equal to, now I'm going to take the positive value of this because I'm looking for the acute basic angle, so 6, 9, 3, 3, 6, and so on. And I'm going to find the inverse, so cos or the inverse cosine of 0.69336 and so on. This is going to give me that value of k, which just want to see. So let's find the inverse cos of, let's say, 0. Now let me just work with the exact value. The exact value will be taking the positive root Okay, give me that 0.8. So let's capture that. Good. So this is the angle. This is the angle. But we are now saying our solution is in the second quadrant. So in the second quadrant, so when we come to the second quadrant, in the second quadrant, we're going to have, let's take back our half of x. In the second quadrant, so what's happening in the second quadrant? If you go all the way from here to there, to find this angle here, it's like saying pi minus that angle there. So let's just say our angle K in this case. All right. So if we take pi minus that, that is pi minus 0.8046 and so on. And once we have that answer, we're going to multiply that answer by 2 times the answer that we are getting from that. So let's see what is it that we are getting as a solution in the second quadrant. So I'm going to do it step by step on the calculator. So I'm going to say pi minus my answer. Then I'll multiply that by 2. So I'm getting 4.6 something. And if I capture that, this is my value of x. Now, if I was to go back to the software, you see this is 4.67. And this point here is the point 4.6 something something. Well, it's not exactly that. Can I move a bit? Right? That is the point I was referring to. Could be 4.67, somewhere there. This is the point. This one is the negative one, so that is not considered. But let us see. So there's one solution. Let's look at where the cosine is also negative, and that is namely in the third quadrant. So in the third quadrant, if we have to find that angle in the third quadrant, suppose I'm talking about this angle all the way from here, all the way up to there. That will imply that it's pi plus k. Okay, so that would be, just going to leave this in red, in blue, pi plus our k, which was 0.8046 and so on. And once we have that answer, we are going to multiply that answer by 2. Maybe I say that's the first answer. And let's see what we get when we do that. Remember, how did we get, I want to work with, how did we get this 0 point? We took the, okay, so I will be saying, we say shift pi plus, well, the inverse cos of the cube root of 1 over 3. So that gives me 3.94 something something. So let's see. And then I multiply this answer by 2. And I get the big value over here. The reason I'm saying big is that if, now you have to consider what is it that we're looking for. And I'm going to go all the way back to my integral, to what x should be. Let me just grab it. From here, we're told that the curve has a stationary point in this interval. So this interval, if I have to even put it over here, now you do know what the value of pi is. Pi is about 3.14, so on, okay? And 2 pi is twice of that. So for you to see that this is, one of these is out of the interval, let's just see what is 2 pi as a decimal equivalence. It's 6 point something. So this angle will be out of our interval. So we're not going to consider this, right? So this one is outside of our given interval. That implies, therefore, x can only be this one over here, which is 4.67. They said we must give this answer correct to 3 significant figures. So we would be saying our value of x therefore is only 4.67. 4.67. Good. But we're not done, because the question is asking us not only for the value of x, it's also asking us for the value of y. How do you know that? Because it says here, find the coordinates of n. Going back to my software, you see this is 4 point something, so we only have to find the corresponding value of x. 1.1, 1 point something is just an estimate. So that's what we need to do. In order for us to find that corresponding value, you take that x value that you have and you put it back into the original equation, the original function, that will give us our output. So to calculate the value of x, of y, we're going to substitute to calculate the y value, substitute x equals to 4.67 into the original function. Excuse my handwriting. Okay, what was our function? Let's go grab it. It's something new that I'm doing these days. I'm just grabbing, I'm not rewriting anything. So I'm just taking a snapshot. Bringing the whole thing is much easier, and I do not make unnecessary mistakes. Good. Let me bring it over here. So I'm going to substitute in here the value of x. Okay. All right. So remember, what was my x value? It was this one over here. So I'm going to substitute everywhere we have an x. I'm going to substitute in here. So this implies that my y would be tan of a half of the value of x, which is 4.6738 and so on, plus 3 sine times a half of 4.6738 and so on. Let's see what our corresponding y value would be if we do that. Now I can go back, see, okay, I don't, here it is. So I'm going to take this value and I'm going to substitute it into my function. So let's just say tan should be in radian mode of half of, let's say we take 4.6738 should be enough, plus 3 sine of a half of 4.6738. Hit enter, you get 1.122. Okay, very close to that. So now that we have our value of x and our value of y, this is our x value, this is our y value, we can now conclude that the stationary point M is 4.67, 1.12. All of this correct, 3SF. Good. I hope it definitely gave you some sort of assistance to do these type of questions.